All right, well, I want to welcome everyone to Healthy Indoor Air Guidelines with Smart Strategies to Do It. This course is brought to you by the Green Home Institute. The Green Home Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. Today, I will be your moderator. My name is Brett Little, and I am the program manager here at the Green Home Institute. As always, our courses are approved for multiple continuing education units. Among them is our own Certified Green Home Professional designation, which is one too many little logos there, but just look at the health one down here. It is approved under the health category. And then also under AIA, Health, Welfare, and Safety, which may make it applicable to your state-based design or contractor license. Now, before we get into it, we always need to give a shout out to some of the cool things all of our members are doing. And so Eco Achievers here, one of our Lead Green Raider members, longtime friends of GHI, were part of two projects, not one, but two projects that just recently won the 2022 Lead for Homes Awards. These are two awesome projects. One of them down in Mexico, Platinum certified and now Lead Zero certified. And then the second one, the Newman residence, was the first Lead V41 certified project in Chicago, and it's not new construction, but it was renovation. So we can transform our existing homes. We don't just have to build new homes. So very exciting work. And you can become a member at greenhomeinstitute.com. Become a member. We'll share your stories. Our members are always doing fantastic things, and we want to learn what you're up to and share those stories. And you get instant access to all of our webinars and discounts on paid trainings and green building certifications. Now, before we get into it, we want to thank one of our top tier sponsors of this session who allow us to do what we do, Build Equinox, featuring the Serve 2. So what we're talking about is fresh air ventilation delivered when you need it, not over ventilating, not under ventilating like traditional ventilation systems. But when pollution is detected, these systems detect that pollution in the house. They ramp up to exhaust it in a very energy efficient manner using a built-in heat pump to make it super comfortable and ensuring that the air is fresh and it's got recirculation, filtration, and again, it's only ventilating as needed. Built right here in the Midwest in Urbana, Illinois, in a factory powered by solar energy. So what more could you ask for? We'll hear a little bit more about them later. And they have one thing, a GeoBoost feature. And so you want to make sure to check out our second tier sponsor here, Enertech. And they've got two great products, GeoComfort or the Hydron module. And so that works, again, paired with the Build Equinox or, of course, a standalone. Geothermal is the most energy efficient heat pump system you can get on the planet. Still to this day, ground source heat pump using the temperature and heating and cooling of the earth, and it can even heat water. And so these systems really great for large scale multi-family commercial projects, community development projects, and they've still got the tax credits available as well. All right, so again, welcome to Healthy Indoor Air Guidelines with Smart Strategies to Do It. Before we get into it, I just want to remind everybody from a LEED standpoint on what we're going to be talking about today and where it fits in with LEED certification. Is that first we have LEED BDNC V4 as well as LEED Residential V4.1. We have a requirement for ventilation. It's always been a requirement. And there's a bunch of standalone local ventilation, which can be handled with the systems we're going to be talking about today. However, we're looking mostly right now at the whole house mechanical ventilation, which is requiring that at the bare minimum compliance with ASHRAE 62.2 2010. So basically what that means for those of you who don't know what that is think of it this way. You've got a home, a certain square footage, and then you have a number of bedrooms, which usually dictates the occupants of the home. From there, you need to have this percentage of fresh air ventilation delivered to the house continuously or intermittently to keep people healthy. And that can be done in a number of ways, but doing it with a smart ventilation system is going to be the best way to do it. So that's clearly using smart ventilations is going to blow this standard, out of the water for compliance with LEED V4, and then LEED V4.1, which complies with ASHRAE 62.2 2016, which we'll talk about a little bit later. Now, if you want to start picking up lead points, here's where these smart ventilation systems fit in under the enhanced ventilation section. First, you've got the ability to use controls. And the controls we're going to talk about today go way beyond what we're looking for here. But at the very least, you're talking about a humidistat control that senses humidity in the air and then reacts accordingly to ventilate that humidity as needed, so it doesn't over-humidify the house. And then second is enhanced whole house ventilation. So again, if you're going to install a smart ventilation system, you're going to want to make sure it's tested and it's flowing at the rate that you need it to be. And so that's where this enhanced whole house ventilation credit comes in and is ensuring, again, when you have these ventilation systems set up, that they're within the standard that LEED is requiring based on testing that it was installed properly. Now, for our Green Star Homes program, if you're following that, we go even further. We're requiring balanced fresh air systems that are installed and tested to hit their requirements of ideally ASHRAE 62.2 2016, though we also allow smart systems to circumvent this ruling for the gold level anyway. And then for the platinum level, we actually are mandating one of two choices. Obviously, if you can do both, which we're going to talk about today being the best. So either you have an ERV or HRV in the house in compliance with 62.2 2016 or 19, or you have a smart system in the house. It may not have recovery, but you have a smart system in the house that detects air quality and ramps up to ventilate as needed. Or like I said, we're going to talk about a system that can do both today, which can earn you an additional air quality badge within the Green Star program. So that's enough for me. I'm super excited to introduce Victor Nino from Build Equinox, Business Development Manager there, to talk a little bit about all of this today. And this is his second time on the show, so I'm super excited to have you back here, Victor. And certainly Build Equinox and our friend Ty Newell, who's hanging out, is no stranger to our show and our events. So it's always good to be talking with all of you and have you back out. And Victor, I will now hand it off to you, and please take it away.
Thank you, Brett, and thank you everybody for attending this webinar. I appreciate your time. Today basically the topic is healthy indoor air quality guidelines. We want to discuss more about how to reach a healthy home, and then the different ways how can we approach that with basically air conditioning processes and smart ventilation processes. My name is Victor Nino, Director of the Business Development at Build Equinox. The outline is more into the basic understanding of indoor air quality. I will start with just defining what is a smart system, why we call it a smart system. Then we want to discuss more about what are the type of pollutants, the effect on health, and then how we want to achieve the healthy indoor air quality now that we know what to address. And it's basically 3 steps: monitoring pollutants, healthy indoor air quality guidelines. Basically, we want to compare to some numbers, and then we discuss more about the mechanisms to reduce the pollutants. At the end of this presentation, we want to discuss more in depth about the sustainability and cost of health, and basically have a very big difference between what we're talking about minimum standards on ventilation and what are the type of healthy standards that we recommend. So a smart system. So I want to start is basically when I say we know comfort, is you and basically all the audience, Brett, me, we know comfort. We know how we make ourselves comfortable. This is a chart of the Psychometric Chart where we put the temperature in the bottom, humidity ratio in the vertical, and basically we could describe any place in the world in here if it's summer, if it's winter, and then we can define air conditioning processes through this chart. So when we are hot, usually when there is a hot, humid day during the summer, we want to be basically in what we call it the summer comfort zone, right about 78 degrees Fahrenheit, maybe a humidity lower than 60, 50%. That's where we want to go. And we can basically change our clothing. We can open windows or close windows if it's too hot outside, and then turn on our air conditioning. And the same with winter. If it's too cold, we want to be more into the winter comfort zone. It's a little bit lower temperature, maybe 68, 70 degrees Fahrenheit with some humidity. And then that's the area that we want to be that. So basically and we dressed up appropriately. We open windows, close windows, turn on the air conditioning, and so on. So that's basically what we do. There is a feedback there. So first of all, nowadays we use a comfort sensor that is a thermostat, typically. Then we compare to some comfort levels. So we set up those comfort levels to something that we like or our family likes. And then if it's outside the comfort level, then we ask the HVAC or air conditioning system or heater to do something. So during the summer, it will be cooling. During the winter, it will be heating. And when we are inside the comfort, that's where we do nothing. Here is where we are saving energy. That's basically the smart system loop, where there is a input signal that is basically the comfort levels. Those are the numbers that we want to reach. There is a control variable that we put a monitor in the place we want to control. And then there is this controller that is going to make the decisions. If it's outside the comfort, then it will basically provide a signal to the HVAC that it will be the control device. And then this is when we talk about smart system, there is always this feedback. There is this feedback and kind of like a variable that is going to tell, provide those numbers or basically a signal to provide to this controller that is going to make the HVAC to do something or save energy when it's already within the comfort. This is smart, or basically this control system. That's what we want to do also. And why in indoor air quality? And why? It's because unfortunately we cannot notice an unhealthy indoor air quality. And when I talk about indoor air quality, it's basically we're talking about three major things: gases, contaminants, tiny particles, and germs. Basically, that's the things that we want to basically watch for. And there are always a wide range of characteristics. They could be odorless or they could be noxious. Noxious we can sense and we can do something, but most of them are odorless. They're invisible and they are visible. Visible like a smoke. We can do something. We can react through our senses. And there are some of them that they are harmless or lethal. And one perfect example is carbon monoxide that is odorless, invisible, and lethal. So we cannot notice what is the amount of carbon monoxide. So we are relying on monitors. So basically then to maintain a healthy indoor air quality, we want to monitor the pollutants. We want to compare those pollutants to this maximum allowed concentration. And then if it's a high concentration, then we need to ask an air conditioning system, a ventilation system, something to reduce those pollutant levels. And if it's low concentration, that's where we are saving energy. So this is what Brett was saying. We're not gonna over ventilate or under ventilate. We're just gonna ventilate appropriate when it's needed. So when we talk about indoor pollutants, what are the type of pollutants that we are breathing that we can find in our homes? So this chart basically has a particle size in the bottom. So it goes from basically 1 millimeter in the right side to basically microscopic to basically molecular level. And then I'm gonna put here kind of like as a reference, human hair. So human hair is about 50 to 70 microns, the diameter. And then we can start with the dust. So there are things that we can see, the heavy dust, the settling dust, but now there are some other type of dust, especially the suspended atmospheric dust that is basically in the microscopic level that we cannot see. Similar with particle contaminants. So we are talking about particles. Here, basically, that it has some diameter of particles. We have ashes. Some of them we can see. Then everything that is going, moving towards the left are more into the microscopic level. Smoke, smog, tobacco smoke, and soot. Those are the ones that now the particle size becomes so small into the 0.1 microns that we are not able to see. Then we have also the biological contaminants, pollen, some particles of pollen we can see. Then when we go to mold spores, house dust mites, cat allergens, bacteria, they're becoming smaller and smaller, where viruses are basically at the end of the spectrum of particles, where basically they are suspended, they are airborne, and we are not able to see. So we need to start thinking about this type of particles and how to detect them. Then we have on the kind of like in the gas side, basically the gases contaminants. We have the carbon dioxide, carbon monoxide. The carbon dioxide is more from human generated, but also from combustion. Carbon monoxide is definitely from combustion. There are other gases from combustion like nitrogen oxides, etc. Radon is something that we want to also watch, and ozone as well, the ground source ozone. We want to watch those gases contaminants. And then we also finally have these volatile organic compounds. A volatile organic compounds is basically complex molecules, carbon based. There are some of them are human generated, like with things that we eat. Basically, when we do exercise, we also not only we exert carbon dioxide, but also we generate some gases as well. From combustion, like when we cook, we generate a lot of gases as well. From building materials, from cleaning products, and from cosmetics. So there is basically all this. So we want to watch all this stuff. Basically gases, that there are contaminants that when they have high concentrations, it may be lethal or unhealthy, and then also particles as well. And regarding, so what we know, and Brett mentioned that there is a very good indoor air quality videos in the YouTube channel for Green Home Institute. This is what we know. We spend considerable time indoors. Somebody mentioned about 90% of our time. Pollutant levels indoors are usually higher than outside, and it's about 2 to 5 times higher than typical outdoor concentrations. And the effects on human health, they're annoying. Some of them are basically bad odors that we just want to get rid of them. But there are some of them that the ones that they are invisible and we cannot detect. It could create irritation, headaches, allergies, asthma. Some of them it could create, basically very serious problems. There are some contagious airborne diseases that we want to also avoid. And then there are long-term effects. If we are exposed for a very long time with high concentrations, it could actually go and cause cancer, respiratory diseases, and in general, debilitating well-being. And I want to have a little bit regarding particle deposition in lungs. And I love this picture is because it's providing how the human, we actually can react for some things, and basically our organism is able to reject some of them. But then the smaller the particle, the deeper it could go to your lungs. And it makes sense. It's just basically a particle that is so small acts like a gas. And then we're breathing all these gases with oxygen, with these small particulates, and it could go as low as deep as reaching the pulmonary alveoli, sorry. So this exposure to fine particles, it could create coughing and wheezing, shortness of breath, asthma attacks, cardiovascular effects, including heart attacks, heart failure, and strokes, and the reduced lung development in children, because the smaller they are, actually they can go through actually or blood cells as well. Of course, we're talking about a type of pollutants. We also talk about concentrations, but also it's important to know the exposure time, and the age and health conditions of the people. This is all part of how sick you can become. So how we want to achieve healthy indoor air quality? So we mentioned that in a smart system, we have to start monitoring pollutants. And that's what I want to discuss a little bit more. So the question is, what can we measure affordably? So yes, we can, there are basically companies that they have very expensive equipment. They can go to your home and then put those devices around the home. But now technology is giving us the opportunity to have these measurements affordably. So what can we do? So we cannot just go specifically on some of them, but the ones that they are immediate health-threatening gases like radon or carbon monoxide, we know that there are monitors that that are exclusively measuring that. Now, carbon dioxide, we're getting familiar that now there is a common to see commercially available in have carbon dioxide monitors, and then also there are now some monitoring systems that they can do volatile organic compounds. We don't know which type of volatile organic compounds. Is basically it's just a sensor that reacts to most of the chemicals, but at least it's helping us to understand that there is some concentration of these gas contaminants in the house and so on. And this is more related to gases. From a particle side, we also are starting to see more regularly or more commercially available particulate matter sensors. So we know about PM10 means particle matter 10 microns. So that means that it could detect particles that they are 10 microns or lower. But you can also find in the commercially available PM 2.5. I think that's the most common one. That is 2.5 microns or lower, the particulates, and the particulate matter 1, that is basically lower than 1 microns. So innovation is making sensors more affordable and accurate. So one of the major recommendations that we have is basically every space should measure at least carbon dioxide and volatile organic compounds. Accurate, but now you can start see sensors that they are going measuring particle, not only in the weight side, but also a particle count as low as PM.1. That means 0.1 microns and lower. They could actually sense those type of particulates. So regarding particulate size matters, yeah. So as we know, the smaller, the deeper you go into the lungs. Now we have some sensors that we can afford that it could help us to detect those particulate sizes as well. So what is the recommended approach for particulates? So we have to be a little bit careful about what are we measuring. So, and it has to do with the size of that. So for example, here I'm just making the human hair. Just imagine that we are using a microscope and we are looking at the diameter of the human hair. So when you're talking about a 10 micron particulate, it will be that would be the relative size. And if you go smaller and smaller, then yes, the particle size that goes into your lungs are basically invisible, microscopic. And so we want to understand is how to measure that. So we want to measure it by weight. So if we measure it by weight, the problem is that we are measuring the bigger particles. So we want to have is basically two types of measures. And here's an example. We want to measure it by weight, but we also want to measure it by just particle counts. And it sounds a little bit kind of like too much, but now the monitoring systems of the pollutant monitors are starting to have that capability of measuring the number of particles through some sensors that can do that. So, and this is an example, and this is just to show a little bit. If you guys see my cursor, this is about this is our 10 particles of a size of 5 microns. It weighs about 0.7, around 0.7 micrograms per cubic meter. That's basically the reading that we got from our monitors. So that weighs about, I'm sorry, yes, it weighs, this is the number of particles, about 10 particles, it will be weighing about 3.5 micrograms per cubic meter. But if you go to the other side, about 0.1 microns, about 80,000 of particles of 0.1 micrometers, it will only weight 0.01. So that's the I hope I'm trying to explain it very well, but it's basically, it's just thousands of particles of very, very small diameter could weigh as much or not even one big particle. So that's why we need to have these two type of sensors. One sensor that is more of a particle mass dominated, that it measures weight, that we want to weight, we want to measure the weight of the big particles, but we also want to count the smaller particles. We want to, so the ones that they are extremely, extremely small, those are the ones that we need to have a sensor that help us count the number of particles just to put those levels. And the reason we are doing that is to start measuring, basically quantifying the number, the pollution concentration, and then to start doing something about it. So our recommendation for monitoring pollutants constantly, we have basically four monitors. We recommend to measure carbon dioxide. Basically that it tells you the amount of people inside, maybe there is some combustion, they're cooking and so on. There is also the volatile organic compounds. They help us to measure some gases that comes from, basically it could be from combustion, from materials, from your furniture, from other places. We also want to measure the weight of the particles that are suspended in the basically in the indoor air. We want to measure it by weight, and also to make sure that we are capturing the really, really tiny particles. We want to also have a sensor that counts those particles. And as I mentioned, those are available commercially. Additional considerations, yes, and this is basically part of your everyday when you have your own home. It's basically, yeah, if you have fuel-based appliances, you should have a carbon monoxide sensor to make sure that we keep those in level, and then check periodically radon sensor, with a radon sensor. So, and then if the radon levels are too high, then that's where you install maybe a radon mitigation system. So now now that we have the monitors, and now and basically the point here is that we are finding these monitors that we can find it commercially available. Now we want to define kind of like what are the maximum levels that we want to compare it to basically see if we want to do something or not. So that's basically yeah, we want to define those maximum allowed concentrations. So first of all, we want to start with what are the benefits of being fresh air. So we want to have fresh, clean, filtered air inside our homes. First of all, is because it cleanses our lungs. It has a lot of oxygen, provide oxygen to our brain, and help us to think better, and in general, it makes us happier. So we want to bring that fresh air in an energy conscious way. And the air outside, hopefully will have usually the concentration of carbon dioxide is around 400 particles per million, and very little gas contaminants, hopefully, and particulate matter. And I'll talk a little bit more about that. So that's the fresh air that we want inside our homes or close to that. And we know that the benefits of the fresh air is not only from a health point of view, but also from a cognition. It helps us to think better. Improves our sleep quality. We can sleep better with fresh air inside our homes, and also help us to be productive, to accomplish more, especially when we're working from home. So the healthy indoor air quality standards that we are recommending is carbon dioxide. We want to keep that below 800 ppm or particles per million. The volatile organic compounds, we want to keep that below 125 parts per billion, sorry. ppb is parts per billion, ppm is parts per million. And total mass of all particulates, that they are 10 micrograms and smaller, we want to have it less than 10 micrograms per meter, per cubic meter. And the total count of all particulates, that they are basically 0.3 micrometers or greater, we want to keep it about 40,000 particles per liter. So those are the four numbers that we recommend. So where those numbers came from is basically based on literature our own experimental research. We know that improves health. They are practical and achievable. This is why we were recommending those. It reduces sickness, improve our productivity, and it can be achieved in an energy efficient manner. And the way is basically using this smart control system. Additional considerations, we want to, and this is more related to the EPA recommendations, that is basically the carbon monoxide, 9 parts per million, and the radon, 4 PQ liter, PQ curies per liter. Those are the ones that we want to keep below. And definitely exposure time becomes important when higher than those values. But those are the numbers right now that we are just recommending based on literature and experimental research. Now, one thing about carbon dioxide and why we want to keep it below 800 parts per million. There is extensive research about the impact of pollutants on health, cognition, and sleep quality and productivity. There are 4 papers that we usually refer to that it basically provides that basis. And in general, based on experience, based on experiments, that's what we are. We also attest to those numbers, basically 800 ppm. But it's basically, yes, many researchers and universities have found that when you start increasing ventilation, you get into this level of carbon dioxide of 800 ppm, that it becomes brighter, the health are better conditions and so on. And this is a perfect example where, I don't know if you guys are familiar with this chart, but it's basically, this is a chart where there were a survey of different people and understanding what is the impact of carbon dioxide in the cognitive performance. So they measure many activities related to the cognitive side, basically how focused you are, how you analyze the information, what is the based on the strategy, how you strategize with levels of carbon dioxide. So here is basically very simple. When the carbon dioxide is pretty high, 2,500 parts per million, definitely there is a problem that impairs initiative, information, approach, strategy. You cannot think that much. But then when you start definitely reducing the carbon dioxide to closer to 600 ppm, basically closer to a fresh air outside, that's where you're starting to see better levels of better levels in the cognition side as well. Notes about volatile organic compounds. Sorry about the error there. Today's ventilation standards do not specify VOC levels, the gas contaminants. First of all, we generate our own contaminants. Basically, yeah, we generate about 2,400 milligrams per hour of volatile organic compounds. Depends on the people, depends on the type of food we eat. Depends also on the metabolism and the exercise and so on. Both carbon dioxide and volatile organic compounds are proportional to metabolism levels. So if there is nothing, there is no cooking, there is nothing other generation, you will see when the carbon dioxide increases, the volatile organic compounds also will increase. That depends on the people, the amount of people, but also depends on the metabolism of the people there and so on. There are also studies that VOCs impair productivity. The same studies that I pointed out also impairs productivity, degrades sleep, same as carbon dioxide, and the maximum levels of volatile organic compounds that we recommend, they are associated to the human generated carbon dioxide that we recommend. So basically, if when the carbon dioxide reaches 800 ppm, there is this level of volatile organic compounds, human generated, that also reaches. That's the number that we are recommending, around between 75 and 175 parts per billion, but we recommend 125 parts per billion as kind of like the threshold for your ventilation system or to do something about it. Other source of volatile organic compounds is basically cooking and gas combustion, wood combustion, fuel combustion in furnace and water heater, and others. Your furniture, if it's new, it might have some volatile organic compounds that comes because of the process, the manufacturing process. The cleaning supplies and also cosmetics will have those volatile organic compounds that we want to get rid of. We don't want to have that high concentration, and that's the number that we recommend. And about particles, I mentioned studies, several studies have shown the impact of the amount of particles, especially the fine particles that we cannot detect, on cancer, stroke, heart attack, dementia, respiratory afflictions. And they have seen that when those levels are reduced, then it will improve those health conditions. However, there is no low safe limit. We haven't found a defined number of particles. Remember that we want to count also the particles. The US Environmental Protection Agency provides a PM 2.5 about 12 to 15 micrograms per meter cubic meter. We just recommend to measure both mass and total particle count. PM to keep it below 10 micrograms per meter cubic. It's a little more stringent of what the USPA is suggesting. And the particle count, we want to keep that with 40,000 particles per liter. That is somewhat practical. So right now, those are the 4 numbers that we are recommending. 800, and we are continuing with research to do more analysis and understand more about those. But for now, we want to recommend 800 for sure. That's carbon dioxide, less than 800 ppm. Volatile organic compounds, we want to keep it below 125 ppb, parts per billion. That's the number that is correlated to basically human generated. So anything higher than that means that there is combustion or there is something else that is creating that those gases. The total mass of particulates, 10 grams and smaller, has to be less than 10 milligrams per cubic meter. And then the total count of the particulate, that they are very, very small, has to be less than 40,000 particles per liter. Those numbers I mentioned, they are based on literature and experimental research. And additional considerations, of course, the major gases that they are lethal, that it could be that they are carbon monoxide. Also, we have to watch that with some monitoring systems. Okay, so now what we are saying is basically we want to do this in basically following the same approach that we do comfort. We need to monitor pollutants. We want to compare with some numbers that we just provide, and then we want to do something. So what are the type of mechanisms to reduce pollutants? So we want to basically, we want to, if it's high concentration, we want to basically reduce those pollutant levels. So how we want to do that? So first of all, we want to understand what is the source. Maybe we want to control that source. That will be a way to do that. We want to do ventilation, basically dilution of using the dilution, bringing some fresh air to mix it with the stale air inside. We want to do filtration and microbe deactivation to take care of basically the biological agents. So our recommendation is that the most effective system is the one that uses them all. So it's not one over the other one. We want to do all these 4 basically processes at the same time. So your system needs to do all this to guarantee an indoor air, basically a healthy indoor air quality with monitoring pollutants. So source control, I think we are understanding the easy explanation is basically, yes, don't do the pollution inside. Like for example, prohibit the smoking in your home, inside your home. One major thing about electrification that we really like is also that helps to remove those contaminants created by combustion. So everything related to gas water heater, furnace, the gas stove generates, because they're running with combustion, generates all these gases, volatile organic compounds, particulate matter as well. So we want, when we get rid of that, and then we move to heat pump water heaters, heat pump for space, heating and cooling, and electric stove, we are basically, yeah, removing that source on site. We improve safety by because yeah, there is no carbon monoxide leaks, and then we know also this is part of having access to this clean electric energy, solar energy, or renewable energy as well. Ventilation, the purpose of ventilation is basically to bring outdoor air that we know, or that we think it is with low concentrations outside, to basically dilute the indoor contaminants. It works for gas contaminants, carbon dioxide, volatile organic compounds, carbon monoxide, radon, etc. Particulates also works for particles, the particle contaminants, and biological particles as well. So we have three types. I think you guys are very familiar with the infiltration, exfiltration, those little gaps that homes have that we want to close, but that's part of the ventilation. We also have natural ventilation when it's in some areas in the country where it's always outside, nice outside. Unfortunately, I live in Wisconsin. We usually keep the doors closed. I'm sorry, the windows closed, the doors closed, most of the year because of the winter and hot summers. But then we are going to rely more on mechanical ventilation. Basically, have a fan that helps us to bring that fresh air inside. For the dilution. Filtration, basically the filtration is the removal of contaminants from the air. This is more for particles, contaminants, and biological particles. There is a removal efficiency that we want to basically watch for. And it's basically the removal efficiency is basically what is the concentration before the filter, what is the concentration after the filter, and that's how you calculate basically the removal efficiency. ASHRAE has this designation of the MERV. You hear a lot about MERV filters, basically the minimum efficiency reporting values. And the way the filter do the removal is basically, there are a few mechanisms how the filter removes. First one, the ones that we understand easier, is basically you have a filter, basically you have a physical wall for the particles. So there are some particles that they will basically impact and stay there. And here the graph is basically showing basically the efficiency of a filter for these big particles. So when you have a very dense filter, basically is really effective for big particles, but then you start losing the efficiency when through impact and interception. When the particles are smaller. And the reason is basically, yeah, a very small particle can go through, if it's a really small particle, it can go through the filter. One phenomena that it's harder to understand is the diffusion side. And the diffusion side, this is more into the microscopic level. Basically, the diffusion is the movement of particles from high to low concentration. And this is a picture that it basically helps us to visualize, like when you put for example, a dye in water, you start seeing the high concentration at the beginning, but then due to diffusion, those molecules are gonna move and then they're gonna basically diffuse. Basically, yes, it's gonna go from high concentration to low concentration until basically the concentration is constant everywhere else. So that's the process of diffusion. In filters, that phenomena also happens. The diffusion happens when now the particles are smaller. The smaller they are, the diffusion effect happens as well. And that's where actually the filter efficiency is efficient for the high particle levels. I'm sorry, for the big size particles, but also depending on the filter, it could be also very good at the lower particle levels. So this is why you're starting to hear recommendations. There are other mechanisms to do the filter removal. There are some of them that depends on it's electrostatic attraction. When you set up a different charge, and those will attract those particles. But in general, the filters that we are familiar with, that is basically the MERV, the filters that are MERV 13, 14, 15, or 12 or 11, they have different removal efficiencies that but they are effective at high levels, but also effective at low levels, at low particle sizes due to the effect of diffusion. And we are interested in that is because the viruses, and the soot are into that lower level. And just last year, the ASHRAE Epidemic Task Force, for example, recommends MERV 13 or higher is due to this type of studies. Microbe deactivation, we recommend ultraviolet germicidal irradiation filters. Basically, they have been used in hospitals and laboratories for disinfection for many, many years. Now they're affordable. We can buy those and then install them. It has a shortwave ultraviolet light that basically inactivate the biological contaminants. And it could be an add-on. So this one do not remove particle contaminants, but basically deactivate the DNA of the biological contaminants, basically killing them. There are now LED lamps. We want basically these devices do not generate ozone production. So those are the ones that we want to install. So when we talk about recommendations for healthy buildings and homes, we talk about basically those three things. So first, ventilation. Ventilation, we want to target 40 CFM cubic feet per minute per person. That we found out through calculations and research, that's equivalent to reaching healthy levels of 800 ppm of carbon dioxide. So those are the numbers that we want to that we recommend for ventilation. For air filtration, based on studies, based on the ASHRAE Epidemic Task Force, MERV 13 or higher, we want to also use that filtration. We just show that it's effective not only for big particles, but for really, really small particles as well. We want to have a very good air recirculation. We want to also recommend that for not only for recirculation, but for fresh air coming in. And I will explain that a little bit better. And air purification. So there are some viruses and other biological agents that might not be removed completely through all this ventilation and air filtration. So we want to also basically kill them. Basically, we want to deactivate them with this ultraviolet germicidal irradiation as well. So that's basically or the recipe for healthy buildings. The healthy part is basically we want to use ventilation. That is basically this dilution of gas and contaminants, particulates and microbes. We know through research that improves cognition, productivity, and sleep. We want to do air filtration, that is basically this removal of particulates, that is going to reduce these respiratory and cardiovascular diseases. And then we also want to add air purification that is more related to microbe deactivation, basically kill the biological agents to minimize the probability of infection. That's basically the three processes that we recommend to maintain a healthy home. And a healthy and safe space, and this is an example, is basically a balance of those three. And this is basically a quick calculation. So if we want to have how much the fractions of microbes, let's think about the microbes, like the flu virus or so on. We have if we are using the three, it's basically the three efficiencies together. So we have basically a fraction removed from ventilation of 50%, a filter that is helping to remove these microbes about 90%, and the ultraviolet killing basically about 85%. Then if you put them all together, basically these three processes will be about 99.3% of microbes removed. So we can do the same calculations for example, just the combustion particles with ventilation and air filtration and so on. Notes about outside fresh air. Yeah, so outside air is not always fresh. It depends on where are you located. There might be some industries close. There might be a heavy traffic close to you. And now we're seeing all these fires in the forest and these big clouds basically moving along the United States and the countries. So the recommendations now is basically filter the outside air as well. So now, before it was not, there was not too much attention paid on what is the type of filters that you put outside. But we are now recommending is basically MER13 to move those filters. To remove those particles and avoiding that. And also the smart system should have the ability to monitor the outside pollution and then close vents when high levels of pollution outside, and use recirculation mode to filter, purify the indoor air in the meantime. That's something that we are recommending as well. And we had some models about just to demonstrate this part. So this is an example where a home, there is a particle outside pretty high, about 50 micrograms per cubic meter, and the indoor air generating. So there are some generation as well inside. And definitely a ventilated, unventilated house. It's definitely, the particles are gonna triple, quadruple. So we wanna do ventilation. But if we do ventilation and we pair it with recirculation, when we close, when it's heavy too high, and then we just recirculate, that's a better way to reduce particulates when outside there are a very high concentration of pollutants. Now let's talk a little more. Now let's tie it up together now with sustainability and cost of health. So when our recommendation is basically when designing or renovating buildings, the top priority is basically achieve a healthy indoor air. This is what we call the human-centric design. Then we put limits on energy, carbon emissions, and cost. So there are some limits. So that's basically an optimization process where we need to basically do those in a very meaningful way, understand what are the basically, the trade-offs, but always thinking about healthy indoor air first. And smart controls, that's a way to reduce energy. Basically, we know that. So basically now that we have a feedback that is gonna help us understand what is the levels of concentration, we compare it to the healthy indoor air quality guidelines that we are providing today, then we can just say, if it's a high concentration, now we have to do something, ventilation, filtration, and air purification. But now when there is low concentration, that's where we save the energy. That's where we say nothing, it's a healthy environment, and so on. Because life at home is dynamic. This is a graph of a monitor in a bedroom of a house that it's about 2,700 square foot. Some 7 air changes per hour of infiltration, no ventilation system. And you're starting to see, there is high levels during the night when they're sleeping, but the levels are very healthy, but when they are not home. So we want to basically use a smart ventilation system. And this is a typical graph of the pollution levels in using a smart ventilation system. Basically, the green bars are basically telling the power of the ventilation. So it's when it's turned on the ventilation. So most of the time the ventilation system is off. But when the levels are starting to get high, that's where the ventilation is acting. So it basically ventilates when needed, and then uses energy only when it's needed. So sustainable building design. So I think we are together here just to talk about healthy indoor air quality, and most of us are basically concerned about the sustainability, basically making the buildings more efficient, more environmentally friendly, and so on. So we definitely are moving beyond building codes. So there are some minimum requirements that the building codes have. We don't want to use them. We just want to go through that, and that's where we use those paths for sustainable buildings, like basically the LEED, the passive house. There are other ones, ASHRAE, and so on. They have this type of guidelines how to get sustainable buildings. And then in most of those, basically they are asking us to achieve this ultra tight enclosure And it makes sense because that's how we reduce the energy losses through infiltration and exfiltration. So one of the things about achieving this ultra-tight enclosure, we are focusing on reducing the energy loss. So we need to add this balanced mechanical ventilation. It really needs to add it. But one of the considerations that we are recommending is ventilation less than 20 cubic feet per meter per person. That's research is showing that it might cause this sick building syndrome, cognitive function decline, and productivity losses. So because this number or something lower than that, it's not enough to remove all those contaminants that will be building up when there are people at home. So basically what we're saying today is basically the same as you are doing, but moving away from standards, from the current building codes that your state have, moving towards LEED, towards passive house and so on. That's what we are recommending as well today. We just want to move beyond those minimum standards. Usually the minimum standards are based on ASHRAE 62.2. That's the minimum standard for ventilation systems. We want also, those are minimum requirements. This is the minimum requirement. We know that it's not healthy, but it's a minimum requirement. We just want to move away from that, move forward, and move beyond, and using more of a smart system, just measuring the pollutants in your home and then compare to these numbers and then basically create a system or your HVAC system to do what it needs to do to reduce those levels. So I want to talk a little bit more about ASHRAE standard 62.2. So there is a distinction between 62.2 that is residential and 62.1 that they are all buildings. I'm talking about this, that is the latest version, 2019. This standard is called ventilation and acceptable indoor air quality standards. Is more related to dissatisfaction with respect to odor and sensory irritation. So it's basically something that we can perceive. And we know that there are some other invisible, odorless things that we are not able to perceive. It does not address the specific pollutant concentration levels, and is based on constant flow. And as I mentioned, it's odor-based. So there is this typical equation that you will see in that one is that the flow rate total, it's proportional to the size of your home. And then you add this coefficient that it depends on the number of rooms, of bedrooms, assuming that one person is sleeping in one bedroom, and that plus one means that in the master bedroom, there are two people sleeping in that bedroom. So that's basically the total. I want to make sure it's there is a difference between the 2010 version that's being called by LEED, but some of the LEED, I think it's version 4, and the version 4.1, for example, it calls the 2016 or higher. 2009, and it's the difference between these two numbers. So 0.01, it might create a very unhealthy defilement. The 2010 version, I would say, is actually, the levels are pretty low on ventilation. They updated the number, but for us, it's still not enough on ventilation. Sorry, Brad, I see your face. You want me to wrap it up?
No. I just wanted to let everybody know who is here and here for the continuing ed that you are approved as of this time for your CEUs. And you can go if you have to get going. It is 1 o'clock Eastern here, but we have more to go to cover. So we want you to stick around to hang out if you can. So we're not wrapping up. We're not doing anything different. Just letting you all know, for the folks of you who are here for your CEUs and you got to get going, I just wanted to let you know, if you've been here the whole time, you are approved to go, but keep going, Victor. So thanks.
Thank you. And I have a few more slides, but basically, yes, the ASHRAE, this is a curve of ASHRAE 62.2 2019 for 3-bedroom, 4 people. And then what I want to show here is basically the concentration. So the concentration of carbon dioxide it gets higher. This is for a 3-bedroom, 4 people. Depends on the size of the house. So the bigger the house, the more ventilation the standard is going to tell you. But for example, for typical homes that are between 1,500, 2,500 square foot, the levels of carbon dioxide, it's high. They are becoming unhealthy. As I mentioned, we want to be in the 800 level of parts per million. Sorry, and we have done basically testing. This is basically a chart of the ASHRAE standard 62.2 2019, certified passive house with HRV, no recirculation. These are acceptable constant ventilation. And we see, here's a comparison. And if you see the line, the red line is 800 ppm. When it's occupied, there is insufficient ventilation when occupied. It's not enough. That ventilation is not enough to get rid of those pollutants that they are inside. Here we're just measuring carbon dioxide and volatile organic compounds. But when it's not occupied, that's where the levels are basically close to levels outside. So we need to. That's where we are providing this smart control. Basically, measure pollutants, the same as a thermostat. Measure something inside your home, and then ask your system to do to reduce the pollutants. So one of the major differences, and here is one basically what are the type of what ASHRAE recommends. As I mentioned, ASHRAE is the minimum, but we want to basically move beyond that to reach this healthy indoor air quality. So from a maximum concentration, there is no definition of what are the maximum concentrations. We provide numbers: carbon dioxide less than 800 parts per million, volatile organic compound 125. PM10 less than 10 micrograms per square meter, cubic meter, and then the particle count less than 40,000 particles per liter. Ventilation, the latest standard is assuming or basically recommending about 20 CFM per person. That's the CO2 is for us based on our calculations is about 1,200 ppm. We want to double that ventilation so we get more of the levels that we are recommending in the healthy levels. And as I mentioned, increasing ventilation means more energy, but putting a sensor inside, then that energy will be basically used whenever you need it. Filtration, the latest standard, they talk about MERV 11 recirculation, basically for HVAC system. MERV 6 if you are having some air coming out from the outside. We recommend basically MERV 13 to both recirculation and fresh intake, and especially the why the fresh intake explained is because of the pollutant, especially outside, might be polluted. So we don't want to bring that pollution inside. Microbe deactivation, ASHRAE doesn't say anything, and we are recommending is ultraviolet, germicidal, irradiation. And the smart controls, ASHRAE recommending this constant flow. There is no feedback. Basically, it's constant control all the time. Maybe sometime now I think they are allowing basically to put maybe a occupancy sensor or a turn on, turn off sensor. But I think the best way, the most efficient way is basically monitor, reduce the pollutants, and when there is low concentration, that's where we save energy. And one of the additional sustainable features that we recommend, and I think everybody is recommending, is basically this energy recovery, basically to precondition the fresh air. We are throwing out this air that it was conditioned already. We want to use that energy of the air that is exhausting to precondition the air that is coming in. All right, so thank you so much for sticking out. Basically, the summary is we want to watch not only gases. Some people talk too much about carbon dioxide. I would say that we have to watch basically all of them: carbon dioxide, gas contaminants, tiny particles, and germs, all of them. There is a wide range. There are some of them visible, some invisible, other less. There are some noxious, someone that we can see, someone that are unable to see. I think we are all aware about the effects of the human health of high concentrations. But then now the technology is helping us to measure and detect those pollutants affordably. So they are now commercially available. You can now start measuring and understanding how your home is based on those levels. We provide some guidelines on the numbers of carbon dioxide, volatile organic compounds, particulates. As I mentioned, the very distinction between weight and particle count, we recommend both. And don't choose only one one process. We have to use them all because basically those three are interacting and basically creating more efficiency on removing all the pollutants inside. And smart control basically is the way to go from our point of view. It's basically, and it makes sense. It's exactly the same principle that we use for thermal comfort, measuring temperature. We want to measure pollutants and then react when the high concentration. And for sustainable building design, so there is path for sustainable buildings. Usually all those like fuels, lead, ASHRAE, they move ahead from far away from building codes. That's what we are telling them. Move away from, move forward, add more ventilation, add better filtration than the minimum requirements to achieve these healthy indoor air quality guidelines. And not use one thing. Basically, we think that maybe one ventilation system it will be enough. We have to use the three: ventilation, air filtration, and air purification. Thank you so much for sticking out and attending this webinar. Now, Brett, you will lead. I think in the next one is basically more about question and answers, if I'm able.
Yeah. Thank you so much, Victor, and everyone for sticking around. Please continue to hang out with us a little bit longer here. Can you see my screen now, Victor?
Yeah, yes.
Okay, great. Yeah, so just real quick as a reminder, if you want to rewatch this session or share it or catch the rest of it, if you can't stick around the whole time, you can access it on our YouTube channel. Go there and subscribe and you'll get an instant update. If you are watching this in the future on demand, not right now, go ahead to the Thinkific platform down in the YouTube comments or to our USGBC channel. Take your quiz, get an 80% passing rate, and you will pick up your certificate. But if you are watching live with us here, you don't need to take a quiz. Don't get all nervous on me now. I know you get a little scared if we're testing you, but you are good to go if you've been here. Search at gutenbergsearch.com, mark it as safe, and you'll get your certificates. And yeah, we got a lot of questions coming in, and I want to get to those questions. And before we do, just a huge thanks to our board of directors, our volunteers, our executive director, Jose Reyna, and all of our top tier sponsors who allow us to do what we do: Mitsubishi, Rheem, April Air, Build Equinox, and many others who allow us to do these webinars and support our work. So yeah, we're going to get into some very sort of general questions, and then we're going to hand it back over to Victor for a sort of after session to really get into the details of the products available through Build Equinox and how they can help you and your clients live healthier, which is why we're here. So yeah, I'm looking through some of a lot of chat going on, and Ty's been really helpful there. So I'm just trying to find some questions that kind of jumped out to me. So if anybody wants to repost those, please put them into the Q&A so I can see them, because there's quite a bit going on here. But one question was, this 40 CFM per person sort of target number, and I want to kind of use my own personal experience to kind of ask the question a little bit here, and that is, I think about like cooking, right, in my stove, right? My stove has a smart ventilation system, so when it detects poor air quality, it turns on the hood and then kicks it out, and then if it detects worse poor air quality, PM 2.5, it turns it on even higher, right? But so for me, it's like, okay, do I wait until the PM 2.5 has built up to let it smartly turn it on? so I waste some energy, blow out some air, and then get polluted while I'm cooking. Because sometimes it takes a little bit of time to detect it. And these aren't your systems, this is somebody else's. But or do I turn it on right away before I cook, so then it never detects that air pollution in the first place? And so I'm asking you that question in the context of a whole home. Are we just constantly pumping in 40 CFM all the time so that pollution levels never build up, we never get exposed in the first place? Or is it okay that it's cycling around, detecting, and then as they start to hit whatever level, then we get to that 40 CFM? You know what I'm saying? Like, is it 40 CFM continuous, or is it intermittent, but intermittent in a more intelligent way?
Yeah, so yeah, thank you for the question and start of the discussion. So let me see, and this is more for personal experience. And usually when you cook, that's where you start turning on that the fan, and exhaust fan at 62.2, actually 62 recommends fans to be about, I think it's 50 CFM, basically continuous. But that's the one that you basically, when you turn it on, when you're cooking and you're starting, and usually you cook it is when the contaminants are getting annoying. That's when you start turning it on and so on. So yeah, I think the smart system should be able to detect that, so you don't have to worry about that. Also, smart systems can integrate also your the fan in the kitchen, and if the more, I don't want to use let's say, yeah, you can add a little bit of innovation in the sense of like putting more sensors in different places of the house that you see that it will help you manage that indoor air quality. Because the location, there are many other things that how to say, parameters that we also take into account. Air distribution, I didn't talk too much about air distribution, but also the location of the sensor. If the location of the sensor is somewhere else, very far from the kitchen, definitely it's not gonna be helpful. So maybe that's another thing that you have to put. I'm sorry. Similarly to a thermostat, if the thermostat is put in the wrong place, there are some areas of your home that it needs to be that it will be hotter than the other ones. So you have to have a thorough understanding of air distribution, where are the location of the monitors, and also if you are able to put more connectivity between the sensors and the fans around your home, even better, and it could be done.
Yeah, great, thanks. And then the next question, you bring up radon, and I'm curious how much you see something like that being measured intelligently. I was surprised to receive a text message from my uncle, who also lives in your great state over there, Victor, and he had set up a whole like kind of crazy system, including an Amazon device where
Mm-hmm.
his radon system only runs when it detects actual radon, and then it shuts down. I don't think it has any sort of it doesn't ramp up. There's a better word for that, but it doesn't. It's just either on or off. And I was like, wow, I need to do that because I'm using a lot of energy here. But is that something you all get involved in as well? That systems are able to detect radon, or is that kind of just something that sounds like everyone kind of has to figure out on their own with like some kind of connection and a smart switch?
Oh yeah, I would say that radon, it has to be addressed separately, in the sense that the mitigation system is the way to go, in the sense of yeah, definitely the smart system will do that, and it could be installed, but I think it's more of a safety approach, the same as a carbon monoxide. We have to take care of that that type of pollutant separately, more how do you call it, more yeah, very seriously, because those high impacts. But I have a personal experience. I bought a commercially available monitor who was measuring carbon dioxide, volatile organic compounds, radon, and then suddenly we have a radon mitigation system installed maybe 5 years ago. And then suddenly I saw the levels of radon so high. I was just like, what is this? And actually helped me understand that the mitigation system was not working.
Yeah.
So it was a great way, just monitoring, understanding, then calling the experts and helping us to basically solve the issue. It was basically the fan. The fan wasn't working, so they replaced the fan. And that was
I had a similar situation. Thankfully, nothing was broken, but the power went out and tripped the radon system, turned it off. Right, and what normal person is going to go and look at their radon system ever, right? You know, all these systems installed all across the country. Who's actually checking if they're working? So yeah, my monitor, you know, showed the levels going up, and you know, sure enough, oh, I just have to unplug it and plug it back in. So, yeah, but yeah, it's important to have those. So, trying to see if there's any other specific questions. You know, how is education on these things getting down to the level where, you know, homeowners are engaging with, you know, like maybe the big box stores or whoever, right? You know, for example, Ian here, and I appreciate what he shared, you know, he walked into the store, asked for low VOC paint. The people at the sales didn't even know what he was talking about, right? Like, what is that? And in this case, I think, you know, I was like, that's okay because most all paint now is low VOC, right? But they should have been like, oh, you're concerned about health. Well, here's no VOC, here's negative VOC paint. Here is our bath fans over here, you know, whatever. You know, it seemed like a missed opportunity. So what kind of education is getting out there where, you know, consumers aren't hanging out on these webinars? I wish they were, we're trying. But when they're getting out to those places where they're making those informed decisions.
Yeah, that's a good question, and I guess it's an open question. Maybe someone will have a better answer than me. I would say is that yes, it just keep the familiarity of the issue, keep under everybody a lot of education, improving the standards. Actually, I'm part of the technical committee for standard 62.2. I just recently joined. I was able to do that, and it's basically trying to bring all this knowledge that we had gotten from with Tiny Walk, just bring it and basically have that discussion and continue the education, and like you are doing, just opening eyes here with all your audience on yeah. First of all, I think everybody understands how unhealthy a home could be. It's just that maybe right now we are now having tools to measure that, and now I think the standards need to move that direction. I don't know if I answered your question properly.
Well, you actually started answering the next question. So good. Yeah. So there was a question about, you know, how do we change these standards? It sounds like you're involved. How close are we to where, you know, ASHRAE starts, you know, putting together a process for smart ventilation, so that it's just built right into the standard?
Yeah, I will give you a report maybe in a year after I've been in a year involvement. I would say it's just that as any industry, like the same as building codes, we ask a lot of questions. Why the building codes are this and not this? It's basically a lot of discussion involved. Also, a lot of agreements needs to be done. There is cost that it needs to be part of the discussion. And I think it's just a little bit complex, the discussions, and this is why maybe they're moving forward slower than we want. Now that we have tons of research information, a lot of information about the importance of monitoring, just solve the problem directly.
And you know, is ASHRAE for people to get like involved? Does it end up going for public comment, or is it pretty specialists that, you know, get to make those decisions? Or
oh yeah, no, there is public comment. Exactly. Yes.
Okay, so maybe you go to their website and sign up for
exactly
notifications, and
correct.
Yeah, they can make that. Well, That's great, Victor. You know, I don't see any other specific questions from like a general standpoint. So, you know, at this point, I'd like to kind of turn it back over to you and just kind of have you tell us a little bit more about Build Equinox and what you all have to offer and help people. I see some specific questions about that. So with that, we will end at least the formal CU session here, and then we'll turn it over back to you to talk us through that. So thanks, everyone, and stick around still if you can. So.
Thank you, Brett. So can I share my screen again? Okay.
Yeah, yep.
Yeah, basically, yeah, a few slides in the sense that like from Build Equinox, I'm very proud to be in this group. I just recently joined about a year ago already. But yes, they develop solutions for healthy, comfortable, and sustainable lifestyle. So those are the three three aspects of a home that we are paying attention to: healthy, comfortable, sustainable, and learn to live sustainable, not to make a major impact on that. The major product that I think you guys are familiar with is this smart, healthy indoor air quality system. It's a smart ventilation system. The SERV2, SERV is basically conditioning, energy recovery, ventilation. The conditioning is because it has a heat pump that also helps you control the humidity in the summer. But basically, and I think, Brett, I think we're talking about a new class, talking more about the energy recovery. So I'm not gonna put too much explaining here. We can set up a class talking about energy recoveries, ventilators. Please go to the website, Build Equinox. That's where we are basically gathering and Tiny Wallets, putting a lot of experimental research, computation analysis on indoor air quality and comfort. That's basically the fundamental basis of basically the presentation that I just provided. Tons of research there. And this is smart ventilation system. Basically, the SERV2 is basically applying everything that I just mentioned. We measure the pollutants. So this has the capability of measuring the pollutants, carbon dioxide, volatile organic compounds. We're moving to measure the particles, basically mass and particle count. Then we use the numbers that I provided, or Build Equinox Healthy Indoor Air Quality Guidelines, just to compare, and then reduce when it's needed. And it does everything, basically ventilation, filtration, and microbe deactivation. That's an option package. But yeah, you can put basically an ultraviolet GB germicidal irradiation in this product, and efficiently, because this is smart. That means when I say smart, it's basically it has a feedback on what's happening in your home. So if you have high concentrations, we just do those three: ventilation, filtration at the same time.
Is it PM 2.5 and 1 or 10 that's part of this?
Yeah, and that's the future development. So we recommend is PM 10. PM 10 is basically, but we are doing both. We are counting and we are measuring the weight. So PM 10, it will measure all the heavy ones, right. And then the particle count, it will measure the little ones.
Now, what about humidity? Because obviously sometimes you want to act, maybe not, but you want to react a little bit differently if your house is starting to get overly humid or starts to dry out. How do you all handle that?
Yeah, humidity is another webinar. That's and I think you have one in YouTube channel. Yes, but humidity is basically, yes, we want to maintain. It depends on the region. It depends on where you are located. So yes, your HVAC system, your air conditioning systems should have some humidity removal. This one will add some more, but there are some areas where really you need to have an additional dehumidifier to try to control those levels. And actually 62.2, I believe, or 0.1. I think they are starting to recommend some numbers. I think I know that Dr. Stephanie Taylor, she recommends something below 60%. So it's as well, sensor technology will help you measure temperature and humidity. If you see that is building up, the place where you will see the most build up, it will be in the bathrooms. That's where all these exhaust fans will be helpful to try to remove that and so on. And efficiently is basically, yes, trying to connect, trying to have the feedback into your system to be able to control it.
Does the heat pump built into this system give additional dehumidification on par, above the energy recovery ventilator?
That is correct, because basically so what we are doing here is the exhaust recovery, I'm sorry, the energy recovery. We use the heat pump in the sense it's like there is going to be we are exchanging heat between the conditioning air, I'm sorry, the exhaust air that it's already a temperature that is inside. So we move it through a heat exchanger. Then and then the other one that it's coming out from the outside. So if it's during the summer, the condenser, I'm sorry, the evaporator. Oh yeah, we're cooling it down. So it's gonna have an evaporator, basically an evaporator, a similar evaporator that the air conditioning will have. That it will be bringing down the air temperature, but because of depending on where you are in the psychometric chart, you also will be removing some of the humidity. So yes, it adds some additional removal of humidity. But in some areas it might not be enough. So you have to have some dehumidifier as well, especially in some local areas.
Sure.
And so what I'm happy about it is being in this team is that we are also working on product development. We want to basically have this approach on basically smart systems, and we have already a pilot project in a school in Illinois where we develop this basically it's a cabinet system. It not only has ventilation but also has a heat pump for space heating and cooling, MER13 filters. Basically, everything that we just apply, we want to put these systems or this type of approach in schools to improve the health on students. We know the benefits of having healthy indoor air in the schools for kids and so on. So we want to have that moment, and we had an opportunity to do that. And the same is with, I think you guys are hearing more and more these integrated mechanical system pods for deep retrofits. Basically is have a kind of like a small mechanical room that you can manufacture somewhere else. Just put it in your retrofit home or retrofit project, and then just connect some piping and some ducting. So we are doing that. So we are also having this or version where we again or first approach is basically maintain healthy indoor air quality in your rooms, and then we integrate it with a heat pump water heater, a heat pump space heating and cooling for comfort, and water heater.
Yeah, so you're saying it actually can be, you see integrated ERVs into ducted systems. Not ideal, but it can be done. I have one too, and so you're saying this could be integrated and function right within the existing furnace or heat pump.
Correct, exactly, yes. So we are integrating a heat pump with the ventilation system all together. Yeah. And then what we want to do is basically this mechanical system where basically we hooked up the duct that is coming in, the return duct to this system. This system could be inside or outside, but also we try to integrate it as small as possible because we want to also put some space for the water heater. So it's basically a unit that will have water heating and comfort, healthy indoor.
Yeah. So, obviously we want everyone to go all electric, but it can be difficult, especially with high electric rates. And so there's up and coming dual fuel systems where, heat pumps can integrate with the existing gas furnaces, right? And they can kind of work in unison with it until it gets really cold. How does your system, could it work like that? Would it chip away at the energy needed using the heat pump. Yeah, is that something you've all thought about?
I'm sorry, if I'm understanding this, basically what would be the energy savings here or?
Yeah, like, so for example, if you wanted to integrate the serve to, which has a heat pump, to you know, take on some of that conditioning and take it away from, you know, the need to burn more gas, or, you know, even until the temperature hits a certain, whatever it might be, you know, like with traditional heat pumps, you know, they might go all the way down to 20, 30, 40 degrees. Yours, I suspect it's not as big, so it might be a higher, but, you know, maybe you just run off the serve when it's 60 degrees. I don't know. Is that something you've thought about, as sort of integrating with existing systems?
Yeah, actually, yeah, that's a very good point. And it has to do with the controls, and that's where we're focusing a lot more on that. But that's a very good point, because if you're outside air, it's basically perfect condition, perfect. We don't want to go through all this. We just want to bring it directly, right? We just want to filter it. That definitely for sure filter it. But if it's already, that's what we call it, free cooling. Basically, it's air that is outside that. This control system also will help you to recirculate. Maybe the problem is not high concentrations of carbon dioxide. Maybe the problem is a lot of particulate matter. So maybe it's from the outside or from other places. Maybe we don't want to. We want to also maintain the energy by just recirculating. We don't want to keep always bringing some fresh air if we don't need it. So maybe just recirculating through the filter. So the control system. There is the capability of having that, how to say that, brain integrated, that it can help us basically decide what to do, what this type of equipment it does. So if we integrate all of them, it's easier for us to manage, because then the air conditioning is not going to do something that the ventilation system is going to do the same or duplicate or so on. So yes, controls is the key.
Right, thanks.
Yeah, and I would say that just visit our website, call us. We basically, there is, as I mentioned, a lot of extensive research about the impact of pollutants, and this is why these are the basis of our fundamentals for conditioning system, for ventilation system. Thank you, everybody. Thank you, Brett, for the invitation. I think we are planning to do a couple more webinars. One of them definitely is talking more about energy recovery. Again, there is a lot of confusion between what is an energy recovery. We think that energy recovery is going to help the ventilation issues. It's part of it. We have to also integrate it and understand a little bit more what is that for. And how can we integrate monitoring systems of pollution and so on. Yeah,
I know. Yeah, we'll definitely, you know, have you all back out to talk about some more things. Do you still have a second for some other questions that came in?
Yeah. Please go ahead.
Yeah, so since we're talking about the serve too, I think, you know, the question is, what is the, you know, cost for a system like this? And, you know, maybe, you know, try to break it apart between install, you know, and I know that's kind of hard to control, the install versus, you know, the actual product itself.
Oh, we're taking about specific questions on the product.
Yeah. Oh, yeah. That was what I thought we were here to do.
Oh, so, I'm sorry. Yeah, no.
If you're not ready for that too, we can.
I'm not ready yet.
Yeah, we can give everybody your email. Well, then
yes,
maybe what I'd rather ask then is, you know, so I'll just tell you from my experience, it has been an uphill battle because of, you know, labor shortage and all sorts of other problems that heating and cooling contractors have to deal with. I want to try to be empathetic here, you know, to work with them on advanced heating and cooling and ventilation systems, right? Going above your standard install. And so, you know, trying to ask someone to do this, you know, sounds to me like an even step above asking them to put in a heat pump or an ERV, which again is, you know, it's a tough sell. You know, a lot of heating and cooling contractors are like, I won't do that. You don't need that. It costs too much, right? or I don't have time, or worse, and maybe you can tell me how this is on your end, it's out of stock because of a supply shortage. So tell me a little bit about, sort of the training aspect, the ease of install. I know this could be a whole nother session, but just briefly, if somebody wanted to start doing this work in their area, how do they get their contractors convinced to do it? And then can they actually get the product? Because of all the material shortages, can you even actually build these right now?
So I would say that, definitely visit us, Build Equinox, contact me. My email is victor@buildequinox.com if you have all those questions about it. In general, I would say that as we focus on cost savings, energy reduction. I think today we talk about, we also have to have a holistic view, and it's the sense of if there are energy bills that we want to reduce, but we also want to reduce the health bills, so the visits to the doctors. And that's where I don't know how, because if we are working on buildings and that's something that is not included. But in general, I think the idea here is basically we have to include, because if we are trying to reduce a lot of energy, we say, well, we cannot afford a monitoring system of pollutants because the question here, it didn't let me to do that. But we are not including that those type of monitoring pollutants are going to be really helpful to avoid some health issues in the future. And that also has some cost in the overall cost. It will be impacted through basically a lot of visits to the doctor, some productivity, let's say the sick days that you have to stay over because you had a disease that it could be monitored or killed by a system. So those configuration, but unfortunately there is no standard that is helping us to do that. However, we see a lot more emphasis on healthy when we are talking about building sustainability. Now those two names, healthy and sustainable, are together. Mm-hmm. So we are moving forward. I think we're just the beginning. We need to move forward and learn from each other.
Yeah. Well, great, Victor. I appreciate your time hanging out with us and educating everyone. And we'll definitely have you all back to keep the conversation going. Where can people go to reach out or learn more or inquire if they, want to, maybe put a serve in their project?
Yeah, you can contact me directly, victor@buildequinox.com. Maybe I'll write it in the chat. Let me see. And then visit the buildequinox.com for more information about the products and about the products, the technology that we have, and also the research that we have done so far. There is a couple more. I don't know if Joyce and Jack is here, but does Victor have comments on product quality and pricing? Not specifically. I have been using. Can I say? Yeah, now I can say next.
I do have to. Yeah, I
you have to call us.
Going now too. So
okay.
yeah.
Sorry about that. But then Joyce and Jack, maybe you email me personally.
Yeah, we're gonna send you all the questions in the chat too.
Okay.
So if there's something you want to follow up with, you can do that too. So yeah.
Okay. Thank you so much, Brandon. Sorry.
Yeah. Take care, Victor. Good to see you.
Have a good day, everybody.
Thanks, everyone. Bye.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.